Good morning, students. Welcome to the first lecture of this week. So we are into the lecture 33 of environmental engineering subject. So we are discussing the unit 3. So in the today's topic is sedimentation process, the design of sedimentation process in the wastewater treatment plant, right? Okay. So in the earlier classes in the lecture 32, 31, we have discussed about the primary treatment methods, that is the screens, types of grid chambers, the process, the design criteria. Okay, so the skimming tank. So these the things we have discussed in the last class, right? So we will see the other methods of doing the primary treatment process in this unit. Okay, right. So this is a wastewater plant where you are discussing at this wastewater management treatment system, right? So these things you already discussed in the unit 1 and unit 2. So these are the sewer pipelines where these are going and collected at the wastewater management plant, right? So this is a process what you are discussing in this unit 3. That is how the raw material is coming, raw waste, raw sewage, liquid waste is coming and falling into the screens. And what are the various types of screens here? What are the various types of screens you are having there? From there, how the water is going into the commuter and how the solid is crushing, how the solid materials are crushing inside the commuter, and the balance solid waste material is coming from the commuter and passing into the grid chamber. So like this, we have seen the grid chamber process also. In the grid chambers, we are having various types of grid chamber process, right? That is the aerated tank process, horizontal type process, and axial flow process. So like this, you have seen the various types of grid chamber tanks, how they are treating the wastewater. Right? Yes. So here the skimming tank. The skimming tank is a chamber. The skimming tank is a chamber so arranged that the floating matter like oil, grease, waste, etc., some of the oils from a machines or from the water coming out in the form of a layer, thin form of layer forming on the top surface of the water, rise and remain on the surface of the wastewater until removed, while the liquid flows out continuously under partitions. So this just like a medium to thick layer of grease, oils, acids, some sort of chemicals, fat, etc., will be settling on the top surface of the water, which will make some disturbances for the flowing wastewater from one chamber to the other chamber. This skimming tank will helps to remove such type of waste material from the tank, and the fluid is flowing continuously under partitions. Right? Next point. It is necessary to remove the floating matter. It is necessary to remove the floating matter from the sewage. Otherwise, what happens? It appears in the form of a scum. Okay, what it appears? It appears in the form of a scum on the surface of the settling tank. So whatever the waste matter, solid waste matter is on the top surface of the water is nothing but a scum, right? So if you see the skimming tank, so at the bottom you are having the air ventilators, air layers where the air is passing inside the tank. So this is a shaft or a rod which rotates which will skim the water. Thereby the scum which is forming on the top surface of the layer, it is settling at that one point and it is further removed, right? Next. It is used to separate the grease and oil and other floating matters, which may adversely affect the effect of the treatment facilities, right? So the tank is the main purpose of the tank is to remove the such type of scum matter on the liquid. The grease may be tend to trap trickling filter and coat the biological flow in the activated sludge process. So this is the next thing what we will discuss in the next treatment process. Next, the floating matter may be collected by the continuous mechanical process, right? So whatever the water is coming from the before process, that is from the grid chamber or from the commuter. So the water is flowing continuously from chambers to chambers, and these are collected on the continuous mechanical automated process, or it may be by manually done process. They have baffled entrance and outlet. They have baffled entrance and outlet. Skimming tanks are now narrow rectangular tanks, just like a grid chamber, having interconnectivity, right? Next, these are used to remove the grease and fatty oils from the sewage. The air diffusers are provided at the bottom of the tank. So from the figure, what we observed, the air diffusers. So these are the air diffusers chambers where the water is going inside the tank. Compressed air applied at the rate varying from 300 to 6,000 meter cube per million. Liters of sewage agitates the sewage, which prevents the settling of the solids. Next, air tends to change the oil and grease. So what happens? This air will tends to change the oil and grease to the soapy mixture. So what is the main purpose of air entering into the water? So air chambers it will diffuse and passes into the chamber. There, what happens? The oil and grease are converted into some sort of soapy mixture. So this mixture is carried out to the surface by the air bubbles. So for example, if you see any natural disasters, natural calamities, so if you see heavy floods or some sort of canals in some cities or some places, whenever the water is flowing from top to surface to bottom surface, some sort of chemical, some sort of other material, manure, some sort of wax, grease, everything will mix in the water in any canals, in any drainage, and will flow. If you see in some places, this all will mix and form a soapy layer and form some air bubbles, form some foam. Tellaga nurugu, pedda nurugu laga form avutundi. Ekkada whenever the water is flowing with a high discharge and going up and downs and adding with the grease, soap, oils, etc., chemicals. If you see some places in the cities or towns, ఒక నురుగు లాగా ఒక వాటర్ మీద పెద్ద నురుగు lumps laga form అయ్యి మీకు కొన్ని చోట్ల కనిపిస్తుంది. So how these are forming? These are forming naturally. So అదే విధంగా in the skimming tanks also, air ventilators ద్వారా, air diffusers ద్వారా, the air is passing into the water and making the oil and grease, whatever the matter you're having on the top surface, oil and grease and other fatty acids into the soapy structure, soapy mixture. This mixture is carried out to the surface by the air bubbles. Air bubbles ద్వారా it is carried away. Some of them which are entrained in it and may be skimmed off. Tarvata chilikin tarvata it will be skimmed away. So if you see the skimming tank here, these are the air diffusers. Understand? These are the air diffusers where the inlet of water is going here, the outlet is coming here. The scum, whatever the grease, oils, fatty acids, other things are forming on the top surface of the this tank is nothing but this top surface is nothing but a scum area, right? It is nothing but scum. Next thing, sedimentation. We'll discuss the next topic is sedimentation. So what is the meaning of sedimentation here? Just it is nothing but a settling thing. So whenever the water is flowing from the chambers, it will settle at every chamber for some time, right? So this is nothing but a settling of water. So this may be defined as a removal of solid particles from the suspension by settling under gravity. So what is this one, sedimentation? It is a process of removing the solid particles from the suspension by settling under gravity. So ఏదైతే gravity ద్వారా large materials కిందకు వచ్చి settle అవుతాయో, so that materials by suspension they are removing. This is nothing but a sedimentation. Next, clarification. It is similar term which usually refers especially to the function of the sedimentation tank in removing suspended matter. So suspended matter ni remove cheyadaniki, suspender matter ni remove cheyadaniki sedimentation tank lopala. So the term which is specially used, which is a function of a sedimentation tank. Okay, right. In the broad sense, clarification could include flotation and filtration. Next definition is a thickening. Thickening in sedimentation tanks is a process where the settled impurities are concentrated and compacted. Okay, the settled impurities are concentrated and compacted on the floor of the tank and in the sludge collection hoppers. So thickening and enti. So in the sedimentation process, in the sedimentation tank, whatever the settled impurities are at the bottom of the tank or compacted or getting అంటే దగ్గరికి చేరి అంటే big forms లో ఉన్నవన్నీ దగ్గరికి తీసుకొచ్చి కాంపాక్ట్ ఫామ్ లో ఫామ్ అయ్యి which is forming on the down floor of the tank and in the sludge collecting hoopers. So ట్యాంక్ కింద అడుగు భాగాన సెటిల్ అయ్యి కాంపాక్ట్ అయ్యి సెటిల్ అయ్యి అండ్ ఇంకొక అదర్ ప్లేస్ ఏంటి ఇట్ ఈస్ ఇన్ ద స్లడ్జ్ కలెక్టింగ్ హూపర్స్. సో స్లడ్జ్ కలెక్టింగ్ హూపర్స్ లో కూడా దిస్ సమ్ ఈస్ forming there. Okay, the concentrated impurities withdrawn from the bottom of the sedimentation tank are called sludge, while the material that floats on the top of the tank is called scum. So sludge and the material which is forming the impurities, the whatever the solid impurities forming on the bottom surface of the tank is nothing but the sludge, and the material that floats on the top of the water, the top of the tank, is nothing but a scum. Right? Now we'll discuss what is the meaning of sedimentation, what is the design of the sedimentation process. Next, solid liquid separation process in which the suspension is separated into two phases. So solid liquid nu separate cheyadaniki, right? In this process we are having two phases of the things. The first one is clarified supernatant leaving the top of the sedimentation tank. Second one is concentrated sludge leaving at the bottom of the sedimentation tank. So two phases dwara the solid ni liquid ni manam veru chesi we will dispose. One is a overflow process, other one is a underflow process. Right? Next, what is the purpose of settling? What is the purpose of doing sedimentation in the sedimentation tank? The first one is to remove coarse dispersed phase. What is the first thing? The first thing is to remove coarse dispersed phase. Second one, to remove coagulated and flocculated impurities. First one is to remove coarse dispersed phase. So coarse ante enti hard ga unna phase ni remove cheyadamu. That's the first function or purpose of settling. The second one is to remove coagulated and flocculated impurities. To remove the coagulated and flocculated impurities. Third one, coagulated or flocculated, my next units to discuss chestunnamu. Next thing, to remove precipitated impurities after chemical treatment. So whatever the impurities you are having in the water, so dani manam precipitation chesin tarvata, once done by the chemical process, it is also removed. That is the main purpose of settling. Next, to settle the sludge, and the sludge is nothing but the matter which is present at the bottom. So dani biomass అని కూడా అంటాం. ఎందుకంటే if it is organic matter we can convert into biomass. Okay, to settle the sludge after activated sludge process and trickling filters. So the trickling filters అనేది మనకి next unit లో వస్తుంది. So we'll discuss there in detail. So these are the main purpose of the settling process. Okay, right. Now see the sedimentation tank process here. So this is a detailed sketch of it. So how the process goes here. The influent wastewater is coming from one tank and it is going on the tank. So at the bottom you are having a channel where the sludge is removed, and is going into the other place for the disposal, land disposal, right? So this is other topics to discuss. ఈ కింద జరిగేదంతా other topic, ఈ పైన ఉన్నది వచ్చేసి one topic. Next, primary settling basin. So the skimming collection. So here what happens at this point where the wastewater is going into the sedimentation tank, the skimming action is also will process continuously. Next, whatever the water is coming from this settling basin is going into the next secondary treatment. So manaki last stage of primary treatment process ఏది, the last stage of primary treatment process is the settlement. That's the settling basin process or sedimentation process. Then తర్వాత next ఎక్కడికి వెళ్తుంది the water will go to the secondary treatment process. Okay, so final గా మనకి ఇక్కడ sludge అనేది ఇక్కడికి వస్తుంది. తర్వాత స్కిమ్మింగ్ ద్వారా మనకి స్కమ్ అనేది బయటికి ఇక్కడ కూడా డిస్పోజ్ అయ్యి బయటకు వచ్చేస్తుంది. So this is the main process of this primary sedimentation basin tank. So if you see in detail, దీని మనము ఈ బ్లూ కలర్ ఫిగర్ ఇన్ డీటెయిల్ గా చూస్తే స్లడ్జ్, సో మనకి ఇట్లా బేసిన్ ఇలా ఉంటుంది థిక్కన్ గా. సో దిస్ అ క్రాస్ సెక్షన్ ఆఫ్ ద ఫిగర్. సో వేర్ యు ఆర్ హ్యావింగ్ డిఫరెంట్ డ్రైవ్స్ ఇన్సైడ్ ద వాటర్. సో the influent is going అంటే water, the influent is going, wastewater is going from one chamber. The baffles or the spaces where it will move in a particular order. So you are having some motor assemblies, the motors are placed outside through the shaft motor connection. These drives are moving. So enduku these drives are moving? Why? Because so the skimming process jarugutundi, right? So what happens here? Water ni manamu we are moving with some sort of action, some sort of velocity. So there will be what happens, whatever the solid sludge, whatever the solid particles, whatever the hard particles which are present inside the water, wastewater, will settle at this point, will settle at this sludge, and it is coming outside, right? So whatever the water is flowing on the top surface, the rigid flight on the skimming position, the scum skimmer is a water level, is a turn track. So మనకి ఇక్కడ ఒక ట్రాక్, ఒక ప్లాట్ఫామ్ ఉంటుంది. సో హియర్ ద బెల్ట్ ఈస్ మూవింగ్ లైక్ దిస్ అండ్ ఇట్ ఈస్ taking the orientation, making this water going into this chamber, and the sludge is collecting at this place. Got it? Right. On the next level of water, whatever the scum is removed at this point, the water is going from the other chamber outlet and it is going to the secondary treatment plant. So this is a thing happening in the sedimentation or settling tank. So see the process, the realistic process, how they are primary settling basins. So before the water is going into the main settling chamber, how the water is settling at the various blocks. So these, the upper layer where you are having scum, the lower layer where you are having the sludge, right? So these are the three phases or images where you can see the primary settling basin process, right? What are the design aspects of a primary basin or sedimentation tank whenever you are constructing or whenever you are studying in any work? See the design aspect. Coming to the first one, the size. So generally the size of the sedimentation tank may be 3 to 24 meters wide into 15 to 100 meters long. So the width ఎంత ఉండాలి? 3 meters నుంచి 24 meters వరకు width ఉండొచ్చు. తర్వాత what is the long? 15 to 100 meters long. So if you see the figure also, మనకి క్లియర్గా కనిపిస్తుంది. So see the length here, how you can see the length ఇక్కడ నుంచి అక్కడికి ఎక్కడికో ఉంది, right? So see the width here, ఇక్కడ నుంచి ఇది ఒక బ్లాక్, మళ్ళీ అక్కడి నుంచి ఇంకొక బ్లాక్. Like this you are having different sizes, ranges from 3 meters to 24 meters wide and 50 to 100 meters long. Next. Circular, 3 to 90 mm diameter. If you are having some sort of circular design of this wastewater collecting tank or sedimentation tank, it may be in a rectangular or it may be in a circular shape of 3 to 90 mm, 3 to 90 meters diameter. Then what is the detention time? The detention time means 1.5 to 2.5 hours. What is the overflow rate? The overflow rate is 20 to 60 meter cube per meter square per day. Next, the type removal effectiveness, typical removal effectiveness. So removal effectiveness ఎంత ఉంటుంది దీనికి? Solids వచ్చేసి 50 to 60%. Biological oxygen demand for 5 days is equals to 30 to 35%. So that is the design aspects of this tank. So if you see any problem for this one, just an example of this problem. So a rectangular primary clarifier, 2.4 meters deep and 4 meters wide, is designed to settle a flow. Of 2,000 meter cube per day and have an overflow rate of 32 meter cube per meters per day. That is what the first one to find. How long should it be? Second one, what detention time will it have? End detention time daniki untundi, right? Next, first one, the length. So how long it would be another. So it is having a given dimensions and a design settle flow. What is the flow rate and what is the overflow rate? Then what is the thing you have to find? You have to see the length. Then what is the overflow rate formula? Overflow rate is equals to flow rate by area. Flow rate by area. What is the flow rate here? 2000. The flow rate is 2000 meter cube per day. Then what is the area here? The area is 4 meters. Right? The area is 4 meters into length. So మనకి ఇక్కడ width ఇచ్చాడు, the width ఇచ్చాడు, depth ఇచ్చాడు, but length అయితే ఇవ్వలేదు, right? So this is a depth, this is a width is given, but this length is you have to find. Okay. Then overflow rate is equals to flow rate by area, that is equals to 2000 by meter cube per day divided by 4 meters into length. Therefore, overflow rate, the overflow rate is equals to 32 and ichadu, right? The overflow is 32. So 32 is equals to, right? What is the length you have to find? So దీన్ని మీరు simplify చేసిన తర్వాత then length ని డివైడ్ తీసుకొస్తే 2000 divided by 4 into 32 is equals to 15.6 meters. 15.6 meters, right? So this is a length how you are getting, right? Flow rate by area formula తీసుకొని overflow rate is equals to flow rate divided by area. Therefore, flow rate is equal to 2000 meter cube per day by 4 meters into length. Therefore, overflow rate ని మనం length rate side తీసుకొచ్చి overflow rate is equal to 32 తో 2000 by 4 ని మనం చేస్తే you are getting 15.6 meters. Then what is the detention time? Then the detention time is equals to volume by flow rate. So the detention time is, so this formulas మీరు ఈ particular topic you have to by heart or you have to understand. So overflow rate is equals to flow rate by area, detention time is equals to volume by flow rate. Then what is the volume here? Length into breadth into height, right? So this is the length, this is the width, this is the length, this is the length, and this is the depth. This is the depth. So the depth is 2.4, width is equal to 4 meter, length is equals to 15.6 meter. Therefore, detention time is equals to volume into flow rate, and the flow rate is this one. Now, after calculating all this one, we are getting 1.8 hour detention time for having this 32 meter cube flow rate. So in the tank, the detention time is 1.8 hour. So when you get 1.8 hour, so మనం ఇక్కడ detention time ఎంత ఉండాలి? The detention time is 1.5 నుంచి 2.5 hours అని చెప్తున్నాం. So మనకి ఎంత వచ్చింది? 1.8 వచ్చింది. Thereby the design is correct. So whatever the rectangular ఎంత తీసుకున్నామో the length, so these are all according to the standards, right? Okay. Next one is primary sedimentation tank. Next one is primary sedimentation tank. The primary sedimentation tank is also known as primary clarifier and is located just after the grit chamber. Grit chamber tarvata left kani right kani. So just after the grit chamber process, so mundu grit chamber tarvata you are having a primary sedimentation tank, which is also known as primary clarifier. It may be rectangular shape or circular shape or a square shape. Usually at sewage treatment plants, so generally at sewage treatment plants, this sedimentation is carried twice. So this process after grit process, it is carried out two ways. Once before the biological treatment and once after the biological treatment. So sedimentation process it is carried two times in a operation. So what is how? First operation, first time is before sedimentation, first time is before BOD, second time is after BOD. So first time is before biological treatment, second time is after biological treatment. Next, the sedimentation before the biological treatment is called primary settling. So edaithe sedimentation before biological treatment chestunnamo, we are calling them as primary settling, and the carried after biological treatment, we are calling them as secondary treatment. is calling them as secondary treatment. Okay, the sedimentation before the biological treatment is called primary treatment, and the sedimentation after biological treatment is called secondary treatment. Okay, next. So in this process of sedimentation, the velocity of the flow, the velocity of the wastewater flow is decreased to such a value that finer settleable will settle to the bottom of the tank. Such settling tanks in which the sewage continuously keeps on moving with the predetermined velocity are called continuous flow settling tanks. So continuous flow settling tanks in eppudu cheptunnam, whenever the velocity of the wastewater is decreased with the fine settleable, ante manaki solid particles eppudaithe chaala chinnaga undi that are settled at the bottom of the tank, such tanks in which the sewage continuously keeps on moving. సో మనకి ఎప్పుడైతే అడుగు భాగాన మనకి ట్యాంక్ అడుగు భాగాన ఎప్పుడైతే మనకి సాలిడ్ పార్టికల్స్ చిన్న సాలిడ్ పార్టికల్స్ ఇంకా మిగిలి ఉంటాయో, సో దాని మీద టాప్స్ ద వాటర్ సర్ఫేస్ లేయర్ ఏదైతే ఉందో, రైట్. సో whenever the sewage is moving continuously in the tank, keeps moving with the predetermined velocity, so whatever the velocities we are mentioned, ఆ velocity తో మనకి కంటిన్యూస్ గా మూవ్ అవుతున్న దాన్ని we are calling them as a continuous flow settling tanks. In olden days, the sewage was used to fill it in large tanks and allowed to remain for some time, and then they were emptied. Such tanks are called filled and draw type tanks. So if you get the heard question of filled and draw type tanks ante enti annappudu, this is the oldest method of disposing the wastewater from the tanks, which are allowed to remain for some time and they are emptied. So this process is nothing but the filled and draw type tanks. Next one. The liquid sewage coming out of tank, the liquid sewage coming out of settling tank, the liquid sewage that are coming out of settling tanks after the process of sedimentation is called effluent, and the settled viscous sewage at the bottom of the tank is called sewage sludge. ఇందాక మనం చెప్పుకున్న type, whatever the solid particles, hard solid particles which are settling at the bottom of the tank, they are calling them as sewage sludge, and whatever the material which is forming on the settling tank on the top surface, we are calling them as the scum process. Next. The principle and construction details of the same sedimentation tank, and we can see the construction of a sedimentation tank. So మీకు ఇప్పటి వరకు have shown 3 figures, 3 or maximum 4. So 4 different types of sedimentation tank. So you can draw any type of sedimentation tank in the exam. Only the thing can be you are having the inlet influent water and outlet influent water. So on the top surface you have to show the scum, right? So the water moving. So here the whatever the solid particles which are collecting at the bottom of the tank are settling down, and these are moved into the sludge removal pipe. So in some cases, some tanks, the tank will be straight. So in some cases, the tank will be slant. In some cases, the tanks will be slant. Okay, so you can draw this side or that side, no issues. So the inlet channel where the water is making a direction and is flowing into the baffles and is going into the other treatment section. Here the sludge is coming out of the plant. You can see in detail the primary sedimentation tank, how it flows. So see here, the length is 70 meters long. 70 meters long into 12 meters wide into 3 meters deep. So the depth is 3 meters. So exactly 1 meter is equal to 3 feet అనుకుంటే 3 meters is equal to 9 feet, అంటే ఒక పూర్తిగా ఒక మనిషి మునిగిపోయేంత స్థలము డెప్త్ ఉంటుంది, రైట్. Then what is the length? The length is 70 meters. Very, very, very long. And what about the width? The width is 12 meters. So if you see the sedimentation tank in real time, so you can see this type of real type of real tanks which are of 70 into 12 into 3 meters. Dead drop. So ఈ retrieval tank తర్వాత మనకి sedimentation tank ఉంటుంది. So when the water is screened coming from the commutators and following the grit chambers, the grit అనేది మనకి కింద చాంబర్ ద్వారా బయటకు వచ్చేస్తుంది, and the water is through the pumps or motors, it are going to other chamber, that is nothing but primary sedimentation tank. Here the sludge scrappers, so మనకి ఇక్కడ పెట్టిన black ఏంటి, it is a sludge scrappers. Okay, so once the water is going into this tank, so through this belts and drives and motors, these are skimmed inside, and the scum is removed through this scrappers where it is placed on the top surface, and the sludge. So see here the sludge. So e dotted lines on the sludge. So primary sludge falls out of suspension under the influence of gravity. So మనకి పైగా ఏదైతే వస్తున్నాయో ఆ వాటర్ లో ఉన్న సెటిలింగ్ మ్యాటర్ slowly form on the bottom layer. That is nothing but a sludge. Next, once the sludge is collecting at one center, so through the hooper, these are coming outside, primary sludge to gravity thickness, and sending into the other places. So whatever the water that is thoroughly treated, going in different scraper system and sludge system. So again at the other end the water is going to the secondary stages, right? So this is a process of doing the water treatment process. So unit is very easy. So only thing is you have to draw the figure and you have to explain any method, right? Understood? Next one, the design specification of primary sedimentation tank. So the hydraulic loading rate is surface overflow rate by settling velocity, that is equals to 0.3 into 0.7 mm per second, right? So the hydraulic loading rate is equals to the surface overflow by settling, that is hydraulic loading Vs is equals to 0.3 to 0.7 mm per second divided by mm per second, 1 to 2.5 meters per hour. Next, what is the overflow rate? The overflow rate, so the overflow rate should be 30 to 60 meter cube per meter square day. Next, what is the detention time? So the detention time is 2 hours. Average we are having 2 hours. What is the depth of the tank? The depth of the tank is 1 meters to 5 meters. What is the BOD 5 removal? 20% to 40% of wastage. What is the suspended solids removal? 30 to 60% wastage. What is the minimum number of tanks required? So we require generally starting tanks of 2 meters. Next, what is the subject accumulated 2.5 kg of wet solids per meter cube of flow. So this sludge process and next unit we will discuss. So like this you are having the various design criteria for designing the body process, right? Next one is types of primary sedimentation tanks. The first one is typical primary sedimentation tank. Second one is circular radial flow tank. Typical primary sedimentation tank, circular radial flow tank. Third one is upslope tanks. So we are not going to discuss all this one. Just what are the types means we have to write these types. First one is upflow tank. Second one is circular radial flow tanks. Third one is the typical primary sedimentation tanks. So hope the time is also less. We will stop the topics here. We'll discuss the next topics in the next class. Hope you understood the class. So if you have any doubts, just mail me or call me or message me, right? So whatever the topics we discussed, so this generally these are all solid and general. These are all the theoretical topics with some sort of figures, right? So along with this, you are having 20% of problems. So the problems also have clearly we have discussed the doubts on the ready-made formulas what you are having, right? So with this, we'll stop the class. So we'll continue in the next session. So these are the figures where you can draw the settling process. So skimming process, the grid process. Tarvat you are having this sedimentation. So you can draw any type of sedimentation process in the exam, right? You can draw this one. You can draw the sedimentation track. You can draw the sedimentation track, or so you can draw that type of the weaves. Only the weaves, all right? Right? Okay.